Hi students, today we have to discuss about electrochemistry and corrosion. So electrochemistry, that means electrochemical reactions, and corrosion, that means destruction and or deterioration of metals or alloys. So in this class we have to discuss about electrochemistry and corrosion. First of all, electrochemistry is a branch of chemistry which deals with the chemical applications of electricity. That means electrochemistry deals with the chemical reactions produced by passing electric current through an electrolyte, or otherwise the production of electric current through chemical reactions. That is the electrochemistry. In electrochemistry, we have to know conductors, non-conductors and insulators. First of all, conductors, that means a substances or material that allows electric current to pass through it. It is called conductor. The ability of a material to conduct electric current is called conductance. Then, for example, acids, base, etc. Non-conductors. Non-conductors are otherwise named as insulators. That means a materials which do not conduct electric current are called non-conductors or insulators. For example, plastics, wood, etc. And then types of conductors are two types. One is metallic conductor, second one is electrolytic conductor. Metallic conductors are the solid substances which conduct electric current due to the movement of electrons from one end to another end. The conduction decreases with increase of temperature. In electrolytic conductors conduct electric current due to the movement of ions in solution or in fused state. The conduction increases with increase of temperature. Types of electrolytic conductors are three. First one is strong electrolytes, second one is weak electrolytes, and third one is non-electrolytes. Strong electrolytes are the substances which ionize completely at all dilutions. For example, HCl, NaOH, etc. Then weak electrolytes. Weak electrolytes are the substances which ionize to a small extent even at high dilutions. For example, acetic acid, ammonium hydroxide, etc. Then non-electrolytes. Non-electrolytes are the substances which do not ionize at any dilutions. For example, glucose, sugar, alcohol, etc. Then the difference between metallic conduction and electrolytic conduction. In metallic conduction, it involves the flow of electrons. In electrolytic conduction, it involves the movement of ions in solution. Electrolytic conduction involves the transfer of electrolyte in the form of ions. In metallic conduction, does not involve any transfer of matter. In metallic conduction, conduction decreases with the increase in temperature. But in electrolytic conduction, conduction increases with the increase in temperature. Metallic conduction, there is no change in chemical properties of the conductor. But in electrolytic conduction, chemical reactions occurs at two electrodes. Then cell technology. First of all, current. Current, that means it is the flow of electrons through wire or any conductors. Electrode. Electrode is a material or a metallic rod which conduct electrons. Anode. Anode is the electrode at which oxidation reaction occurs. Then cathode. Cathode is the electrode at which reduction reaction will take place. And then electrolyte. So electrolyte is a water soluble substances forming ions in solution and conduct an electric current. Then anode compartment. Anode compartment is the compartment of the cell in which oxidation capsule occurs. It contains only one electrode, that is named as anode. Cathodic compartment. Cathode compartment is the compartment of the cell in which reduction of reaction occurs. It contains only one electrode, the named as cathode. Then cell is a device which consisting of two half cells. The two half cells are connected through one wire. The next, electrode potential. So electrode potential, that means a metal consists of metal ions with valence electrons. When the metal is placed in solution of its own salt, any one of the following reaction will occur. First one is positive metal ions may pass into the solution. That means M, that gives N plus N electrons. Oxidation reaction will occur. Otherwise, positive metal ions from solution may deposit, for example, N plus N electrons, that forms M. That means a reduction reaction will occur. In first example, zinc electrode is placed in zinc sulfate solution. When zinc electrode is placed in zinc sulfate solution, zinc goes into the solution as zinc 2 plus ions. Now, the zinc electrode attains a negative charge due to the accumulation of valence electrons on the metal. The negative charges developed on the electrode attract these positive ions from solution. Due to this attraction, the positive ions remains close to the metal. And second example, copper electrode is placed in copper sulfate solution. When copper electrode is placed in copper sulfate solution, Cu2 plus ions from solution deposit over the metal. Now, copper electrode attains a positive charge due to the accumulation of Cu2 plus ions on the metal. The positive charges developed on the electrode attract the negative ions from the solution. Due to this attraction, the negative ions remains close to the metal. The diagram is shown in figure. Negative ions are surrounded by the positive ions, and also positive charges are surrounded by the negative charges. Thus, a short of positive or negative ions is formed around the metal. This layer is called Helmholtz electrical double layer. This layer prevents further passing of the positive ions from or to the metal. A difference of potential is consequently set up between the metal and the solution. At equilibrium, the potential difference becomes a constant value, which is known as the electrode potential of a metal. Thus, the tendency of electrode to loss of electrons is called the oxidation potential. At the same, the tendency of an electrode to gain electrons is called reduction potential. Factors affecting electrode potential. The rate of the above reaction depends on nature of the metal, the temperature, the concentration of metal ions in solution. Single electrode potential. So, single electrode potential is termed as E. It is the measure of tendency of metallic electrode to lose or gain electrons when it is in contact with a solution of its own salt. Then standard electrode potential. Standard electrode potential is termed as E naught. It is the measure of tendency of a metallic electrode to lose or gain electrons when it is in contact with a solution of its 1 molar concentration of its own salt at 25 degree Celsius. Then derivation of Nernst equation for electrode potential. We have to derive Nernst equation for electrode potential. We have to consider any one of the redox reaction. That means N plus N electrons. This gives M. So oxidation and reduction reaction takes place simultaneously. The reaction is termed as redox reaction. So for a such redox reaction, free energy change del G and its equilibrium constant K are interrelated as del G is equal to minus RT ln K plus RT ln product divided by reactant. That is equal to del G naught plus RT ln product divided by reactant, where del G naught is the standard free energy change. This equation is known as van Hoff isotherm. The decrease in free energy minus del G in this reaction involves the transfer of n number of electrons, and then n is the Faraday of electricity will flow. If E is the EMF of the cell, then the total electrical energy NFE is produced in the cell is minus del G is equal to NFE. At the same, minus del G naught is equal to NE naught F. So minus del G is the decrease in free energy. The del symbol denotes decrease. Minus del G naught, that means decrease in free energy change. So comparing these two equations, you have to name as minus NFE, that is equal to minus NFE naught plus RT ln product, that means M divided by Mn plus. So dividing this equation by minus NF, finally the equation is E is equal to E naught divided by NF plus RT ln Mn plus. And then final Nernst equation, that is E is equal to E naught oxidation plus 0.0591 divided by N log C. That is the Nernst equation for electrode potential. So application of Nernst equations are, it is used to calculate electrode potential of any one of the unknown metal, and is also corrosion tendency of metal can be predicted. Measurement of single electrode potential. So it is very impossible to determine the absolute value of single electrode potential, but we can measure the potential difference between two electrodes potentiometrically by combining them to form a complete cell. For this purpose, reference electrode is used. Standard hydrogen electrode is the commonly used reference electrode whose potential has been fixed as 0. The EMF of the cell is measured and it is equal to the potential of electrode. In some cases, saturated calomel electrode is used as the reference electrode. Reference electrodes. Standard electrodes. The electrode potential is found out by coupling the electrode with another reference electrode, the potential of which is absolutely fixed as 0. The important primary reference electrode used in standard hydrogen electrode, and also standard electrode potential of which is taken as 0. It is very difficult to set up a hydrogen electrode. So other electrodes are called secondary reference electrodes, like calomel electrodes are used. First one is standard hydrogen electrode. That is an example for primary reference electrode. The construction of hydrogen electrode is, hydrogen electrode consists of platinum foil that is connected to a platinum wire and is sealed in a glass tube. Hydrogen gas is passed through the side arm of the glass tube. This electrode, when placed in a 1 normality of HCl and hydrogen gas at 1 atmospheric pressure as passed, forms a standard hydrogen electrode. The potential of standard hydrogen electrode is 0 at all temperatures. It is represented as Pt, H2 1 atm, then slash H plus of 1 molar concentration. E naught is equal to 0 volt. In a cell, when this electrode acts as anode, the electrode reaction can be written as H2, that gives 2H plus 2 electrons. When this electrode is act as cathode, the electrode reaction will be written as 2H plus 2 electrons that forms H2. So reduction reaction will take place. The diagram of standard hydrogen electrode are shown in figure. So limitations of standard hydrogen electrodes are it requires hydrogen gas and it is difficult to set up and transport. And it requires considerable volume of dist solution. And the solution may poison the surface of platinum electrode. And the potential of the electrode is altered by changes in pressure. These are the limitations of standard hydrogen electrode. Then secondary reference electrode, saturated calomel electrode. The construction of saturated calomel electrode. The diagram is shown in figure. It consists of glass tube containing mercury at the bottom, over which mercurous chloride is placed. The remaining portion of the tube is filled with a saturated solution of KCl. The bottom of the tube is sealed with a platinum wire. The side tube is used for making electrical contact with the salt bridge. The electrode potential of calomel electrode is plus 0.2422. Thus represented as Hz, Hz2Cl2, KCl, E0 is equal to 0.2422 volt. If the electrode acts as anode, the reaction is 2Hz, that forms Hz2 2 plus 2 electrons. Hz2 2 plus 2Cl minus, this forms Hz2Cl2. Finally, the equation becomes 2Hz plus 2Cl minus, that forms Hz2Cl2 plus 2 electrons. That means oxidation reaction will take place at anode. If the electrode acts as cathode, the reaction is Hz2Cl2, that gives Hz2 plus 2Cl minus. And in second step, Hz2 2 plus 2 electrons, this forms 2Hz. Finally, the reaction is Hz2Cl2 plus 2 electron. This forms 2Hz plus 2Cl minus. Reduction reaction will take place. So the electrode potential is given by E calomel, that is equal to E0 calomel minus RT divided by 2F ln A. Then measurement of single electrode potential of zinc using saturated calomel electrode. The saturated calomel electrode is coupled with another electrode that is named as zinc electrode, the potential of which is used to be determined, since the reduction potential of coupled zinc electrode is less than E0 of the calomel electrode. The calomel electrode will act as cathode and the reaction is Hz2Cl2 plus 2 electrons, thus forms 2Hz plus 2L minus. Finally, E0 zinc, that is equal to minus 0.7603 volt. Electrode potential of some metals with respect to the EMF series or otherwise electrochemical series. So electrochemical series, that means when the various electrodes are arranged in the order of their increasing values of standard reduction potential on the hydrogen scale, then the arrangement is called electrochemical series. The electrochemical series as shown in figure. The table is shown in figure. Various electrodes are arranged on the increasing values of their standard reduction potential on the hydrogen scale, that is the EMF series. Significances of EMF series or applications of electrochemical series. First one is calculation of standard EMF of the cell. The standard EMF of the cell E0 can be calculated if the standard electrode potential values are known using the following equation. E0 cell, that is equal to E naught right hand electrode minus E naught left hand electrode. Its second application is relative case of oxidation or reduction. That means higher the values of standard reduction potential, greater is the tendency to get reduced. At the same, fluorine has higher positive value of standard reduction potential and shows higher tendency towards reduction. Lithium has highest negative value and shows higher tendency towards oxidation. Then third application is displacement of one element by other. Metals which lie higher in the EMF series can displace those elements which lie below them in the series. For example, we may know whether Cu will replace Zn from the solution or vice versa. We know that the standard reduction potential of Cu and zinc. Cu E naught Cu2 plus divided by Cu, that is equal to plus 0.34 volt, and E naught Zn2 plus divided by Zn, that is equal to minus 0.76. So Cu2 plus has a greater tendency to occur Cu form than zinc 2 plus has for occurring zinc form. So Cu2 plus has a greater tendency to occur Cu form than Cu2 plus for occurring zinc form. So fourth application is determination of equilibrium constant for a reaction. The standard electrode potential can also be used to determine the equilibrium constant K for the reaction. So we know that minus del G naught, that is equal to RT ln K. So ln is equal to 2.303 log. So finally the equation is 2.303 RT log K, that is equal to minus del G naught. From this you have to determine log K. So log K, that is equal to minus del G naught divided by 2.303 RT. So log K, that is equal to N F E naught divided by 2.303 RT. So minus del G naught is equal to N F E naught. From the value of E naught, equilibrium constant for a cell reaction can be calculated. Then fifth application is hydrogen displacement behavior. Metals with negative reduction potential will displace the hydrogen from an acid solution. For example, zinc reacts with dilute sulfuric acid to give H2, but silver does not. Why? Because zinc plus H2SO4, this gives zinc ZnSO4 plus H2. E naught zinc is equal to 0.76 volt. The metal with the positive reduction potential will not displace at the hydrogen form from an acid solution. Silver Ag plus H2SO4, this forms no reaction. So E naught Ag, that is equal to 0.80 volt. Then sixth application is relativities of spontaneity or redox reactions. Spontaneity of redox reaction can be predicted from the EMF values of the complete cell. If the E naught values of the cell is positive, the reaction is spontaneous. If the E naught values of the cell is negative, the reaction is non-spontaneous. In general, element having lower reduction potential can displace another metal having higher reduction potential from its salt solution spontaneously. Then the types of cells. So cell is a device which consisting of two half cells. Each half cells consisting of an electrode placed in an electrolytic solution. The two half cells are connected through one wire. The following are the types of the cell. One is electrolytic cell, second one is electrochemical cells. Electrochemical cells are otherwise named as voltaic cells or galvanic cells. In electrolytic cells are the cells in which electrical energy is used to bring about the chemical reaction. Electrochemical cells are galvanic cells. Electrochemical cells are entirely different from electrolytic cells. The cells used for electrolysis and are called electrolytic cells, whereas in electrochemical cells chemical energy is converted into electrical energy. Galvanic cells are electrochemical cells in which the electrons transferred due to the redox reaction are converted to electrical energy. So, cell diagram or construction is shown in figure. Daniel cell consists of zinc electrode as dipped in 1 molar zinc sulfate solution and a copper electrode dipped in 1 molar copper sulfate solution. Each electrode is known as a half cell. So, two solutions are connected by a salt bridge and then two electrodes are connected by a wire through the voltmeter. Reactions occurring in the cell. At anode, oxidation reaction will take place in the zinc electrode by the liberation of electrons. So, this electrode is called negative electrode or anode. At cathode, reduction reaction will take place in the copper electrode by the acceptance of electrons. So, this electrode is called the positive electrode or cathode. Reaction is zinc, this forms zinc 2 plus 2 electrons. So Cu2 plus 2 electrons, this forms Cu. So finally the equation is written as Cu2 plus zinc, this forms zinc 2 plus Cu. The electrons liberated by the oxidation reaction flow through the external wire and are consumed by the copper ions at the cathode. In salt bridge, it consists of a U tube containing saturated solution of KCl or NaNO3 sodium nitrate in agar-agar gel. So it connects the two half cells of the galvanic cells. The functions of salt bridge: it eliminates liquid junction potential and also it provides the electrical continuity between two half cells. In conditions for a cell to act as standard cell, the conditions for an electrochemical cell to act as a standard cell are: the EMF of the cell is reproductive. The temperature coefficient of EMF should be very low. Then representation of cell diagram. First one is a galvanic cell consists of two electrodes. One is anode and another one is cathode. And second one is the anode must be written on the left hand side and also cathode must be written on the right hand side. And the anode must written by writing electrode metal first and then electrolyte. These two are separated by a vertical line or semicolon. The electrolyte may be written by the formula of the compound or ionic species. The cathode must be written by writing electrolyte first and then electrode metal. These two are separated by a vertical line or also semicolon. The two half cells are separated by a salt bridge which is indicated by writing two vertical lines. Then difference between electrolytic cells and electrochemical cells. In electrolytic cell, electrical energy is converted into chemical energy. But in electrochemical cell, chemical energy is converted into electrical energy. In electrolytic cell, anode carries positive charge. But in electrochemical cell, anode carries a negative charge. In electrolytic cell, the cathode carries negative charge. In electrochemical cell, the cathode carries positive charge. In electrolytic cell, the electrons supplied to the cell from the external battery. That means electrons move in through cathode and comes out from anode. But in electrochemical cells, electrons are drawn from the cell. That means electrons move from anode to cathode through the external circuit. Then in electrolytic cell, the amount of the electricity passed during electrolysis is measured by coulometer. But in electrochemical cell, EMF produced in the cell is measured by potentiometer. In electrolytic cell, the extent of chemical reaction occurring at the electrodes is governed by the Faraday's law of electrolysis. But in electrochemical cells, the EMF of the cell depends on the concentration of the electrolytes and the chemical nature of the electrode. So in this class, we have to discuss about electrochemistry and its types and cell and its types. So thank you.